All right, so in this video, I'm going to be going over the answers to the Chapter 10 practice quiz, the circles practice quiz. So you can see that I have my first 6 answers here. And the first question I'm actually going to go over is the proof. And the reason I'm doing this is so that you can check your answers. If you got them all right, you don't have to wait for me to try to scroll and find when I'm going over number 5 or number 6. You can just kind of see what the answers that I have are. And then you can see how your proof matches against my proof. So, okay, we were given that the 2 circles were congruent. And so that means that all of the radii that are drawn are going to be congruent in the circles. And we were also told that BC and CD were congruent to each other. And we wanted to show that the inscribed angle A and C are congruent to each other. So, all right, let's see how I began. So I said, since the chords BC and CD are congruent, their central angles, angle BPC and CQD are congruent. So remember, if chords of congruent circles are congruent, their central angles are also going to be congruent. Okay. Then I said, by the Srirem theorem, the remaining parts of their supplements, APC and EQC, are also congruent. Hey, there you go, Srirem. You're immortalized in a YouTube video that dozens of people will watch a couple of seconds of. All right, so I have angle APC and EQC congruent. Let me actually mark that on the diagram so we can kind of follow what we're doing. All right, so APC there is congruent to EQC there. Okay. Then I said, since the circles are congruent, each of their radii must be congruent. So PC is congruent to QC and EQ is congruent to AP. And I bet you can kind of see where I'm going with this. We have those two, we have these two, and now we have enough for not there. There we go. There. So now we have enough to say that the 2 triangles are congruent by side angle side. Or I said side angle, but I do mean side angle side. I'm going to edit that out in the post. All right, so the triangles are congruent by side angle side. Thus, by CPCTC, angle A and angle E are going to be congruent. Okay. Are there other ways of doing this? Probably, but this is what I saw. This is what I saw first, so I thought this was the most efficient. Okay. Now let me go through the rest of these problems. Okay, definitely one of these tomorrow. So we are given the larger circle has a radius of 20, the smaller circle has a radius of 7, and they're tangent to each other. Find the length of the common external tangent. So, as we've seen before, we're going to draw both of those in. That's 20, that's 7. The distance between these things are 27. And we go parallel to AB, like that. Where's my right angle? My right angle is right here. If this is 7, that's 7, and this thing here is 13. So I'm going to now use the Pythagorean theorem to find my missing side there, which is the same as side AB. So 13 squared plus x squared is 27 squared. So 169 plus x squared is equal to 729. So x squared is equal to, I don't know, where's my calculator? 729 minus 169 equals 560. And when I take a square root, I know that 4 goes into 560, but I'm betting 16 does also. So divide by 16. Yep, 35. So x is equal to rad 16 times rad 35, which is 4 rad 35. And that's where that comes from. Okay, next. The diagram below, KJ is tangent to the circle. KJ is 24. RJ is 18. Find the area of the circle in terms of pi. Okay, so I'm thinking Pythagorean triple, and when I see 24 as a medium side or any side, there are so many possibilities, but the first one that comes to mind is 7, 24, 25, and that's what I have here. A 7, 24, 7, 18 is 25. So the area is going to be 49 pi. All right. In this problem here, we're told that is 48. So I get 42 on the other side, and that's where the measure of arc BC comes from. BAC is everything in the circle but 42. So that's going to be 360 minus 42, which is 318. AD, well, if I have 42 there, I have 42 there. AD is going to be the 90 and the 42 for 132. ACD going all the way around there, it's the, let's see, I have 180 degrees there, and then this 48. So that's going to be 228. And the last one is ADE, so all the way around there. So basically everything but that right angle. So that gives me 270. Okay, it's a walk-around problem, and there is a shortcut to the walk-around problems. The opposite sides of the quadrilateral have to add up to the same thing. So if AB is 34, and DC is what we're looking for, let's find out what the opposite side should add up to. BC is 32, and AD is 41. So 41 and 32 makes 73, and that is going to be equal to 34 plus x. So that means that x has to be equal to 39. That is the easy way to do a quadrilateral walk-around problem. All right, this is not a quadrilateral, so we might have to do this a little differently. Here we're told PR is 20, and the radius of the circle is 4. So I can get 4 going that way. Remember, radius drawn to a tangent at the point of tangency makes a right angle, and that's also 4. I have 4 right angles. It's a rectangle. Consecutive congruent sides. It's a rhombus. So this thing is a square. So I have 4 and 4 there. Okay. They want us to find the perimeter of the triangle if that is 20. Okay. So this is x. This is also x. This side is going to be 20 minus x. This side is also 20 minus x. So let's add up the sides and see what happens. I have 20 plus x plus 4 plus 24 minus x. I'll actually move this. All that's going together. So I'll just put it on the next line. 24 minus x. All right. I don't know what x is, but I do know they cancel. And what I'm left with is 24 plus 24, and that gives me a perimeter of 48. All right, and the last question, here I am told that GT is 25, KT is 14, and JG is 40. Find GZ. All right, draw in kind of a radius, but I'm going to go perpendicular to KT, and remember that's going to split it into 2 equal parts. So that means that if I call this point x, xt is 7, and gx is 32. So if I just redraw the triangle here, I have g, x, and j. So gx is 32, gj is 40, and what is jx going to be? Well, this is a 3, 4, 5. This is 4 times 8. That's 5 times 8. So this side has to be 3 times 8, which is 24. So that is 24. But the question is asking to find GZ. So what I'm going to do is find out what the radius is and then subtract that from 40. Okay, so how do I find out what the radius is? Let me get rid of some of that stuff. So I'm going to draw in this radius. We know this was 7. That was 24. Oh, it's a 7, 24, 25 right triangle. So my radius is 25. So that means that JZ is 25. So how much is left over for GZ? Well, 40 minus 25 is 15. Okay, if you guys have any questions, don't hesitate to email or ask tomorrow morning.